Hi friends, in this session we study about the operations of complex numbers. So in operation of complex numbers, we study about the addition, subtraction, multiplication and division. Before study about the operations of complex numbers, I would like to tell you something more important regarding complex numbers. So in the last session we have studied about the iota, which is equal to square root of -1, which is also called the unitary imaginary number it is also called, or it is denoted by italic I. So look at here. If I is equal to square root of -1, we make the square of both the sides, we get I square is equal to -1. If I have to find the I cube, then I could write in this way: I square into I, law of indices is per the power will add it will make I to the power 3. So we know that I square is -1 and multiplied by I, so it is minus I, the minus iota. Now if you have to find out the value of I power 4, then you could write in this way: I square into I square, which is equal to -1 into -1, because the I square is equal to -1. So you put here -1 into -1, minus into minus, plus, and 1 into 1 is 1. So I power 4 is equal to 1. Now through this we could simplify so many sort of questions regarding this. So if I have to find out the power the value of I power 13, so what we have to divide this 13 by 4. 3 times 12, so we get here 1 is remainder. So that is, we could write in this way: I power 4 into 3 plus 1, so it will make 1, so we get here I. Similarly, if we have I power 53, so we could divide this 53 by 4 1 times, 4 3 times 12, here also again we get 1 remainder, or in this way we get the value of I power 53 is equal to I. Similarly, if we have I power 54, I power 55, so if we 55 divide by 4 1 times 4, 1 remainder here, and take down this 5 here, 4 3 times 12, and remainder is 3, so it is equal to I power 3, which is equal to minus I. Look at here. So in this way we could find the value of any power of I through now we start with the operations. So the first operation what we have to study is the addition. Look at here: addition of two complex numbers z1 is equal to a plus bi and z2 is equal to c plus di is defined as follows: z1 plus z2 is equal to a plus bi plus c plus di is equal to a plus c plus b plus d into I. So look at here, this is similar to grouping like terms. Real parts are added to real parts and imaginary parts are added to imaginary parts. Just look at here. We have a is the real part, here c is the real part, so we are adding real parts here, and b is the imaginary part and d is the imaginary part, so we are adding here. B and D are the imaginary parts, so we are adding here imaginary parts. So in this way we could simplify this. Now we take one tutorial example: 3 minus 7i and minus 2 plus 5i. So look at here how we add this. So 3 minus 7i plus minus 2 plus 5i. So now I open this bracket: minus 3 minus 7i plus minus 2 plus 5i. So look at here, the like terms are 3 and 2. Minus 2 are the like terms. We add this first. So 3 minus 2 plus minus 7 plus 5. Minus 7 plus 5. I am keeping common. So 3 minus 2 is 1, and here minus 7 plus 5 is minus 2, and this is I. So finally we get here 1 minus 2i. This is the summation of 3 minus 7i minus 2 plus 5i. So in this way we could add two complex numbers. It is very simple. We have to add the real parts with the real part and the imaginary part with the imaginary part. Now look at second operation of subtraction. It is also similar as the addition operation. The subtraction of two complex numbers z1 is equal to a plus bi and z2 is equal to c plus di is defined as z1 minus z2 is equal to a plus bi minus c plus di is equal to a minus c plus b minus di. So look at here. This is similar to grouping like terms. Real parts are subtracted from the real parts and imaginary parts are subtracted from the imaginary part. The same example we are taking here. Example 2, subtract 3 minus 7i and minus 2 plus 5i. So look at here how we solve this. We subtract in this way 3 minus 7i minus 2 plus 5i. Okay. So we get here 3 minus 7i. First we open the bracket, minus into minus plus 2 minus plus minus 5i. So here we get the summation of like terms. So 3 plus 2 minus 7i minus 5i. We get here 3 plus 2 5 minus 7i minus 5i, which is minus 12i. So this is our answer for this question. 5 minus 12i is the subtraction of minus 2 plus 5i from 3 minus 7i. Now the third operation we see here multiplication. Multiplication of two complex numbers z1 is equal to a plus bi and the z2 is equal to c plus di is defined as follows. z1 into z2 is equal to a plus bi into c plus di is equal to ac minus bd plus ad plus bc I. However, you do not need to memorize the above definition, as the multiplication can be carried out using properties similar to those of real numbers and the added property I square is equal to minus 1. So I explain you here, as we multiply the expressions in the real number, the same way we have to use here. Look at here, 3 minus 7i into minus 2 plus 5i. Is it clear? Now first we multiply 3 with this factor. So 3 minus 2 plus 5i. Now minus 7i we write here and again multiply the same factor, minus 2 plus 5i. So it is minus 6. 3 into minus 2 minus 6. 3 into 5 15i. You got here minus into minus plus 7 2 times 14i. It is 14i. Minus plus minus 7 5 times 35 and I into I is I square. So look at here, minus 6 plus 15i plus 14, the like terms are there. So we could write here 29i. Sorry. Like terms are here, so we could write 29i and here minus 35. So I square, we know that it is minus 1 as we have seen earlier. So minus 6 plus 29i plus 35. So look at here, we could add these like terms. So minus 6 plus 35 plus 29i. So we have to subtract the opposite signs are there in both the numbers. We subtracted 35 minus 6 is 29 plus 29i. So this is the multiplication of two complex number. In this way we could easily multiply the complex number. It is the very pretty and easy way to multiply. Now the fourth operation we study about the division. Division of two complex numbers z1 is equal to a plus bi and the z2 is equal to c plus di is defined as follows. z1 divided by z2 is equal to a plus bi divided by c plus di. what we have to do, the a plus bi c minus di over c plus di c minus di. Here what we have to do, I explain here. We use the multiplicity property of the complex number and its conjugate to divide two complex numbers. We first multiply the numerator and denominator by the complex conjugate of the denominator. So we have to take the denominator is complex conjugate c plus di. We take the conjugate of this c minus di, and this conjugate we multiply numerator and denominator, and then we do the same process as we have done in the previous multiplication operation. So we take one example for this also. So we have to divide 9 plus 4i by 1 plus I. So first I write down this here. 9 plus 4i divided by 1 plus I. I have to divide this. What we will do? We will multiply the conjugate of denominator in the numerator and denominator. So 1 minus I, the conjugate of 1 plus I is 1 minus I. Here also 1 minus I. So now we multiply this, the numerator and the denominator. So 9 into 1 minus I plus 4i into 1 minus I. In denominator also, in denominator you see here 1 plus I and 1 minus I. If we multiply a plus b into a minus b, you get a square minus b square. So it is 1 minus I square. Now we multiply this 9 minus 9i plus 4i minus 4i square and 1, because I square is minus 1, 1 minus 1. So 9 minus 4i plus 4i, it is minus 5i because of the like terms, and minus 4i square is again minus 1, and 1 plus 1 in the number minus minus plus 1 plus 1. So we have in the numerator 9 minus 5i plus 4 over 2. So the like terms we add, 9 plus 4 is 13 minus 5i divided by 2, or we could write in this way, 13 upon 2 minus 5i over 2. This is the division of this 9 plus 4i by 1 plus I. So in this way we could easily divide two complex number, taking the conjugate of the denominator, multiply this in both numerator and denominator, and get it the simplification of this. We find out the division of the complex numbers. So thank you for this session.